So hello and welcome on my Spline Design course. In this video we will talk about the basic principles of 3D graphic, or better to say the basic principles of good looking 3D graphic made in Spline app, because 3D theory is pretty big and huge and we are not at the professional 3D course. So today we will talk about basic things we need to understand how to work with 3D in Spline. And this tutorial will have two parts. So first is understanding 3D. 3D means 3 dimensions. So let's say when we design something in Figma or Sketch or Paint, any other graphic tools like that, we working in 2 dimensions, X and Y. X and Y axes we use to position object in the space. So let's take a look at this example. Here in Figma I have this rectangle. This rectangle is an absolute center of the workspace. Look at this position row here. It's 0 everywhere. When I'm moving my rectangle to the left, you can see how the X value is decreasing. This happened because I changed the position of my rectangle, but as because it is rectangle in 2D space, the counting starts from the left side of my rectangle, here. So when my rectangle is in the center and it has 0 in X and Y here, it's not in the real center, it's in the beginning of the coordinate axis. So the score comes from the point that is located on the bottom left corner of the rectangle. But in 3D, it's not so useful. In 3D, if you want your object be aligned in the perfect center, you want to see your object here. So the score should come from the absolute center of the object, in case of rectangle, from here. And in Spline, every object put into the viewport has its own center, which is displayed by these set of little arrows. This thing has different names: origin, pivot point, orientation axis, but I like the pivot point, because this thing has a few purposes. First, as I said, it shows the center of our object, so the counting of the position in space starts here. The second, these arrows can help us understand the position of our object in space. So these arrows represent the global axes, and as because, for example, the Y arrow looks up, this means our object is not upside down now. If I will have the object which is upside down, just rotate it like this arrow will look like this, looking down. Also, using these arrows, we can move our object to the left and right, up and down, front and back. And with these arcs, we can rotate our object, so rotation will be around this pivot point, around the center of our object. But sometimes it's quite hard to manage the position of an object using this pivot point. So in Spline, when you put your object to the viewport, you can use this section in the object panel. When your object selected, here you can manage the position by this row. So the x-axis is about the left or right position, y is about up and down, and z is front and back. Then here you can rotate your object. So as because the x-axis is this red line, right? Imagine that this is something like a skewer, and we kind of shrunk out our cube on a skewer. How do you expect it will rotate? So in case of x-axis, it will rotate like this. It rotates back and forth. In case of y-axis, left and right. And for z, which is this axis, like this, like meat on a skewer. So when you work on some model, my advice to you, first thing you should do after you put any object in the viewport, be sure that it's an absolute center. To do this, check the position. It should be 0 everywhere. Or select your object by right-click on mouse and just call a context menu and select Reset Position. So now your object in the perfect center. Also, you can select Reset Rotation if it was put it in a wrong angle. Then, the thing you can and you will do a lot is resizing. Every object by default has some size, and if you need to change this size, there are a few ways how to do it. First, you can use these size row here under the position and rotation rows. X is about width because the x-axis is responsible for left-right direction. We change size in this direction. Y is height and Z is depth size. And you can see how our object is changing size. It's still staying in the center. In Spline we don't have any dimensions like pixels or millimeters, we just have numbers. But in orthographic projection with zoom equal 100%, this size similar to pixels. But you don't need to worry about it, believe me. Other way to resize your object is to use the object container. When you select your object, you will see this selection with light gray cubes on the edges and dark gray cubes on faces. Pulling the light gray cubes will allow you to change size of your object, but as you can see, I'm changing all sides differently at the same time. It can be quite useless when you want, for example, change only height while width and depth stay the same. In that case, better to use these dark gray cubes, which will change only one direction. For example, to increase the height, I will put this cube up. But if you switch to the orthographic projection, change size with selection container would be much easier. You can pull just to side and not worrying that you will change other dimensions accidentally. And if you want to resize all directions evenly while pulling the light cube, press Shift K, so it will scale like this, or Shift Option, Shift Alt for Windows, then object will resize from the center. You also can scale your object, but here's my advice: do not scale your object by this scale section if you want just make it smaller or bigger. Better to use size row. But if you, for example, have a group of objects, it's quite hard to adjust every object separately. So in this case, you can use scale. And when you scale, better to scale all dimensions at the same time. So before scaling, you need to click on this lock icon, and then you can evenly scale all sides. But if you will scale only one side, it will destroy your model, and it will look like this. Not so beautiful. If you've done something wrong, you always can reset scale or transform and bring your object to the default state. When you understand how to put your object to the viewport, how to move it or rotate, now you should be comfortable with orienting in the space, how to look at your scene from different angles. By default, when you create a new file, you look at your scene through the personal camera. Remember that I show you that in the project panel we have this viewport drop-down with selected personal camera. This is our eyes right now, so to orbit scene and look to the scene from different points, you need to press Option for Mac users or Alt for Windows and start drag by mouse, like this. Try to do this until you will feel confident. Remember, you can always reset the view position by this reset button. So when you orbit scene, you actually orbit the camera. Look at this example. This is how spline works. This is our viewport, the axes X, Y and Z. This is our cube, which is in the center, and this is a camera. By default, it stands here. So when you orbit scene, you orbit the camera, like this. To zoom, you can use mouse wheel with pressed Command button, Control for Windows, or pinch your trackpad if you work from laptop, or use this zoom tool. By default, zoom is 100%. You also can pan in viewport, so let's say you don't want to rotate to the left, you just want to shift to the left, so then you can press space and start drag like this, or swipe by 2 fingers if you have a trackpad. It's quite important to understand how to orient in space and be confident, so try to have some practice. Remember, in one of the previous videos, I told you about the difference between orthographic and perspective projections. Switching between these projections while the creation process, select the projection which is more suitable in that moment, but also be sure with which projection you want to go when you will be ready to export your scene. So now you know that you can put your object to the viewport, you can move it by these arrows or using the position row, rotate it by these arcs or using rotation row. You can change the size using selection container, navigate in the viewport by orbiting, zooming and shifting. You can always reset position of the personal camera and you can reset position and rotation of the object by context menu. So now let's talk about next 3D basics. We will talk about 3 key important things when we work with 3D and how our eyes understand that this is a 3D graphic. And also, these 3 key things will help us to make our 3D looks more realistic. I can create something 3D looking in Figma, for example, and I think you might have seen something like this before. Something what is looked like 3D but was drawn in 2D graphic tool. Of course, it's not a real 3D, it's just an imitation of 3D, but why that looks so 3D? So key things how it helps to see that as a 3D is light and shadows, context and details. Let's start from the light and shadows. We see objects in real life because these objects reflect the light. With this reflection, object shares to our eyes information about shape, color, distance, etc. So light is very important. And let's imagine you want to make a photo of something, some object on the table. Usually you will always have some source of global light, right? It can be the sun or some lamp in your room. This light source will illuminate our object from one side or another. So some part of our object will be lighter than another part we'll have some shadows. And shadows also quite important. Shadows draw the silhouette. So let's take a look at this example. How do you think? What is it? Circle? Ellipse? But what will happen when I turn on some light? Now you can recognize it's a sphere. But you're looking now on a flat screen. How you understand that this is a sphere? Because your brain already knows that is sphere. When we have light like this, we will have light part here and dark part here. When you will work with light, and also in one of our tutorials, we will set light, and it will look like how photographers set their light to make a photo of some objects. We will set a global light, we will add some contour light, we also will use some tricks and hacks to make our 3D look more realistic with light. So the next key thing is a context. While light and shadows can help us understand the silhouette, the shape and form of our object, context can help us understand the material, composition, and also will bring our 3D to more realistic view. Let's have a look at this example. So, can you say me what you see? I mean, what is the type of material is this object? It's hard to say because we don't have enough information. But what will happen when I add another one object behind this? Now you can say that we have something like a glass, matte glass or transparent plastic, but you understand this thanks to this sphere, right? So this is a very simple example of how context can help us understand better what is going on here. This is a power of the context, provide additional information. And now let's talk about the third key thing, details. Well, this is really more about how to make our 3D graphic looks more realistic, because in real life, any object isn't perfect. It always has some signs of wear or environmental influences, deformations, so when we see something absolutely clean, symmetrical, our brain will understand that something isn't going well. Let's have a look at another example, how details is help us to create realistic picture. Let's go back to our glass, because this is one of my favorite examples. We understand that is some kind of glass, as because we can see through this object another object, but we still don't have enough information what is this material is about. So let's add some details. First of all, as because this is a glass, let me add some reflections, because glass can reflect, and I found that in Spline you can use madcap material to add cool glass reflection and light dispersion imitation. And the final touch, as example how details could help to make 3D more realistic. And as because in our world objects are not perfect, I will add some scratches on the surface, so I intendedly show imperfect. In Spline I can use a bump map to do this. Yes, in Spline, details mostly can be achieved by materials, and in next section about object modeling, we will see how to work with materials, but for now let's have a summary. To work in Spline with 3D, you need to know, remember and understand next things. 3D is a three-dimensional graphic, which means you work with 3 dimensions, x-axis, y-axis and z-axis, left and right, up and down, front and back. In Spline we have 2 ways of projections, perspective, which is natural, and orthographic, which is also can be used in some stilistics, like orthographic isometric view. And how to achieve good looking or even realistic 3D, you always should remember about 3 key things, light and shadow, context and details. So with all these new knowledges, we are ready to go to the next section, modeling from scratch, where I will show you how to create complex model, work with light sources, materials, and we will create our first 3D character. See you.